Okay. So this one we did. We went a little over on time, so I had to switch that. This one is Mestranol. Let's see. Brand name for a oral contraceptive, which means you take a pill that it's a birth control pill. So find out from your parents how their birth control pills went, and if it didn't go so well, don't assume that it's going to go well for you. Genetic gets passed down. So I'm an accident, but it would have been because of the pill probably. I think they had them. I doubt that's what the deal was. But anyway, they're not 100% effective. What about this guy? That carbon, I need 4 bonds. That carbon, I need 4. Okay, we don't have to worry about that ring. What about this carbon? Well, it's got 2 hydrogen on it. That one has 2 hydrogen on it. That's not a deal. This carbon has 1 mess this way, a different mess that way because that bond's there. And this, yeah, and this isn't symmetrical. So I'm thinking this one is chiral center. Yeah, because this way isn't the same as this way, isn't the same as this way, isn't the same as that way. So I think that's a chiral center. This one, this way is not the same as this way. That's different. There's a hydrogen. I think that's a chiral center. Okay, how about this way, that way? I think this is a chiral center. This one has 2 hydrogens. No, no. This one is a chiral center, I'm pretty sure. That one's a chiral center. Not that because that triple bond. 2 hydrogen, 2 hydrogen. I think you got 5 chiral centers there. So, all right. After D is E. Make sure I drew that right. I don't remember. Okay. Did I? Phenyl, H, and I think it's drawn okay. So let's go through. These 2 phenyl groups are the same. Let's see. This is fexofenadine, a non-sedating antihistamine. And when you have an allergic reaction, your body's putting out histamines. An antihistamine blocks that allergic reaction. So for example, if you get deathly allergic to bee stings, it's because bee stings you it's not the bee sting in you, it's your body's allergic reaction to it going bonkers on the overload on the response. So I used to be, I don't think I'm even allergic to it anymore, but I used to be very badly allergic to poison ivy. And so you take a Benadryl, which is an antihistamine. Well, some antihistamines make you drowsy. And a non-sedating antihistamine would be an antihistamine that doesn't sedate you, so it would not make you drowsy. So fexofenadine is a non-sedating antihistamine. In other words, it's an allergy medication that doesn't make you sleepy. All right. So these 2 are the same, so that carbon there can't be a chiral center. What about this one? I've got this mess is different from this is different than this way. There's a hydrogen on there, so that I think is chiral center. 2 hydrogen, no, 2 hydrogen, no, 2 hydrogen, no, 2 hydrogen, no. 2 hydrogen, no, 2 hydrogen, no, 2 hydrogen, no. I've got this and that, and the OH is different, and the hydrogen, I think I've got one there. These have 4 individual bonds. It can't be, that's methyl, it can't be that one. So I think you have 2. That one and that one. Virusept, used in the treatment of HIV. Honestly, I don't know much about HIV because I always got bored with the T cells and all that stuff. So I was never very interested in that particular problem. So don't know much about Virusept. I'm checking my drawing. Everything looks pretty good. Okay. Not going to have any of these be a carbon or a viral or chiral center because you have to have 4 bonds to do it. Or I mean, tetrahedral bonds to do it. And I don't have any on a carbon until I get to here. And none of these are. Okay, so let's take a look at that one. I got that group, this, 2 hydrogens, no. This one, that group, this one's a chiral center. So this mess, this mess, this mess, and a hydrogen. What about here? I've got this mess, this mess, this mess, and a hydrogen. So that one is 2 hydrogens, no. 2 hydrogens, no. 1, 2, 3. This one should be a chiral center. 2 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen. I think I got one too many bonds. Put carbons in there maybe. Let me say this way, and that way, and a hydrogen. This one is 2 hydrogen, no. Let's see, this way, this way, this way, and a hydrogen. This one is. This has got methyls on it, so no. Going through that quick, I think I got these 5. See what you come up with on that. I got those answers in the book there. Let me see if I have the same thing. Didn't look at them. That's the same. 1, 2, 3, 4. That one's the same. That one's the same. Oh! I have this one as a chiral center, and it is not. And the reason why is I got in a hurry. If you rotate this nitrogen is on the opposite end. So if you flip it around, you get the same answer either. So this one is not a chiral center. Then you only have one on there. I got excited about doing that the same way. Let's see, this question I have the same as what they've got. Okay, draw all the constitutional isomers of ice. This would be what? Bromobutane. And we did this earlier in the year, and I don't remember how many isomers there were, and I drew these 4, and I got bored and didn't want to do it anymore. But you could have a bromine on this end. Okay, you could have bromine on this end. And then you could make that, instead of carbon, 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 be carbon, 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 and iso like this, like isopropyl. And then I could put the bromine on the second position and have a methyl group and an ethyl group. Or I could have the bromine on the second position and have methyl groups all the way around. And I think that's all of the constitutional isomers, but like I said, I got bored with it and called it good. So if you know of more than this, let me know. And it says identify the isomers that possess chirality centers. This one does not. This one does, because I have methyl, ethyl, hydrogen, and then of course the bromine. So there's a chiral center. No on this one because I have 2 hydrogen. No on this one because everything is the same around. So I think this is the only one. Let me know if you get a different answer on that one. I got bored with it and quit. Because if I kept going to find them all, it's not like I'm going to learn something new. It's just tracking down something you're forgetting. Okay, this was for 5-6. A little interesting because do you expect the following compound to be chiral? Explain your answer. That's arguable. There are no chiral carbons in here. That has 3 hydrogen on this carbon. These have not got tetrahedral bonds in them. 3 hydrogen on this one, 2 hydrogen on that one. You could, however, have non-superimposable, if you call this a chiral center, around the phosphorus. And I don't see any reason why you can't. Yes, you could have non-superimposable you can have different non-superimposable versions or stereoisomers of this one. So it looks exactly the same. The constituents that's on there as they are put in they are the same. But you could have like a right-hand and left-hand version of that. You could have all of this ethyl group in front and the methyl group behind, and that is not the same. If you did a mirror image of it, of this one, and then if you did a mirror image of this one, and then flip the mirror image around, they do not superimpose. So yes, I think you can have chirality there. It's just not on the carbons, it's on the phosphorus. Okay? So continue. Next week we'll continue with the enantiomers and onward. Okay? You may get a little ahead on those videos. I think it's easier to watch the videos than to get it out of the book. So the videos are taking us all the way into, you know, page farther than we are, all the way up to optical activity right here. I can't show you. In fact, I don't even know if we have Polaroid films to show you some of that stuff. So I'll have to check that out.